So this is said trig functions of any angle. Now what you're going to be doing is a lot of finding ratios. Okay, so we can find our ratios from our like some old hippie caught another hippie tripping on acid, right? From a triangle, right? Now the other way that we find ratios is the unit circle too, right? So remember what the x coordinate is the cosine, the y coordinate is the sine, the tangent is the sine over the cosine, the cosecant is reciprocal of sine, and so forth. Okay, I'm not going to go through all that. So I kind of have a saying here that when you want to find your trig ratios, you're either probably doing one of two things. You're looking at a triangle, okay, at this point, or the unit circle. So the way the software teaches you is different, okay? They'll teach you other ways to find it. I just use two basic things: triangles and the unit circle. All right, so let's look at this one. Okay, now the examples in the software will use formulas that they call them X, Y, and R. Okay, and what you have to do is you have to memorize is that cosine is the X over the R, and then the sine is the Y over the R, and then the tangent is the Y over the X. Okay, well, instead of doing that memorization, it's much more beneficial to draw triangles here. Okay, now let me step back and look at, so you'll see what I'm talking about. It's asking for the 6 trigonometric functions. It's asking for the ratios. Okay, so when I want the ratios, I'm either going to get it off the unit circle or I'm going to get it off a triangle. In this case, I'm going to do a triangle. Okay, so that says -4, 3 is the ordered pair. So what I'm going to do is I'm going to draw a triangle with those numbers on it. Okay, now before I draw the triangle, I'm going to draw an angle in that quadrant. Okay, now where would -4, 3, what quadrant would that be in? Yeah, second, right? Okay, so in the second quadrant, and when you draw your triangles here, it's really important, like, be consistent and draw them the same way. You always draw the angle. Now the angle, in the standard position angle, ends up being the hypotenuse. And the way you make a right triangle is you always form a right angle with the x-axis. So I say right angle with the x-axis, and then your theta at the origin. Okay. Now what I'm going to do is use my ordered pair to label my triangle. Okay. So what they're saying right here is that this point that we drew the angle, is -4, 3. So let's say, how would we get there? Well, we would go what? Left 4, right? And then up 3. Okay, now we could find our hypotenuse, couldn't we? Okay, so that's a triple. Y'all know the hypotenuse on that one automatically? 5. Okay, now the other thing is when you do them on the ordered pair, you do them on the coordinate plane, you're leaving yourself open to having negatives. Okay, the hypotenuse is always positive. Okay, so always keep the hypotenuse positive. Now, naming the 6 trig functions, all we have to do is look at the triangle. Okay, so we do sine theta, okay, cosine theta, tangent theta, so forth. All right, so how do we find sine from our triangle? Yeah, opposite over hypotenuse, so that would be 3/5. Okay, cosine is adjacent over hypotenuse, so that would be -4/5. And then tangent is opposite over adjacent, so that would be 3 over -4. So I'm just going to say -3/4. Okay. Now, how do we find these? Cosecant and secant and cotangent. They're reciprocals, right? So cosecant would be the reciprocal of sine, so it would be 5/3. All right, what's secant now? -5/4. All right, and then cotangent would be -4/3. Okay. Now, you have this problem and another type of problem are similar, and usually when kids miss this on their quiz or something, what they miss are the signs. It's really, really easy to get a sign wrong, like to have a negative when it's a positive and vice versa. So especially not so much when you're doing the homework, but when you guys get a quiz question like this, check your signs. And here's how you can check the signs. What all seniors take calculus. Now we're in the second quadrant. So S in the second quadrant tells me that what does that tell me? That what sign should be? What do these mean? Well, all as in all of them, S as in sine, T as in tangent, C as in cosine. It tells me which ones are positive. Okay? So what should be positive right there should be sine. And if sine is positive, so is cosecant because it's the reciprocal. So sine and cosecant should be positive, but the rest of them should be negative. Okay? Now, is that what I have? So do I have sine and cosecant positive up there? Yep. Are the other four negative? Are the other four negative? Yes. Okay. Now, we had a quiz on this last year. It wasn't actually a question like this. I'll tell you what it was later. What kind of question it was. But we had somebody in particular. Did I tell y'all this story? Missed it, and they missed the sign. They got real angry, and she's not here today. It was Christina. You remember that from last year? Stats? Remember? Oh, y'all were probably walking out. She threw her pen down and so she was like, fudge. Except for she didn't say fudge.
Emotions were running wild.
Yes. So she was very upset because all she did was she missed a sign. Okay? And it was a problem like this where it wasn't really an ordered pair one. It was another type. But she had a number right there and she had it as positive. Okay? And so if that's going to the left, that should be negative. All right. Now we might skip over this one. I'm going to just get y'all's reaction here. So this would be 12, negative 12. All right. Where would that one be? Yeah, fourth quadrant. Okay. Y'all want to do that one out, or this is going to have a radical in it? That would be the only thing. Let's do it with that radical. All right. So here we go. All right. Y'all said fourth. Okay. So we draw it to the fourth, and then we form the right angle how? To the x-axis. There we go. Okay. And theta at the origin. Okay. So this side would be 12, and this side would be negative 12. Now, I'll teach you a shortcut on this one. Because the two sides are basically the same, they both measure 12, it would be a 45, 45, 90. You remember the shortcut on the 45, 45, 90? Where you just take the leg and you multiply it by square root of 2. So this would just be 12 square roots of 2. Now, if you don't remember that, you can do the Pythagorean theorem, but watch what happens. Okay? All right, 12 squared would be 144. Okay? And negative 12 squared would be 144. Now, that would be your hypotenuse squared, so that would be 288. Okay? And then you take the square root. Now, how would you simplify 288? Well, how did you get there to begin with? 144 and 144. So 144 times 2, so it would be 12 square roots of 2. So anytime you have like an isosceles right triangle, the legs are the same. And so the hypotenuse would just be the leg times the square root of 2. So if I had a leg of 7 and another leg of 7, the hypotenuse would be 7 square roots of 2. Okay, it's a little shortcut. Now, all we have to do from here is name the ratios. Okay, so sine, all right, what's sine? Opposite over hypotenuse. So negative 12 over 12 square roots of 2. Okay, now, y'all, this software is very inconsistent about rationalizing. There's sometimes it lets you go and not rationalize it, and then sometimes it makes you doesn't. It never tells you when or when not to. Okay, so I always rationalize because it will always take the rationalized answer. Okay, now in this case it would not take that because you can simplify. You know, the 12s would cancel. Okay, so that would leave you negative 1 over square root of 2. Now, I think it would actually take negative 1 over square root of 2. but then again, it might not. Okay, so if it's me, I'm rationalizing. Okay, so if you rationalize that, that would be negative square roots of 2 over 2. All right, now cosine. Okay, cosine is adjacent over hypotenuse, so this would be 12 over 12 square roots of 2. Now notice the pattern, especially in this problem. The only difference in the sine and the cosine is the sine was negative. Okay, so let's get to the answer. It's going to be the same thing as the sine one, right? Except for it's going to be positive. All right, so that would just be square root of 2 over 2. Okay, now tangent. All right, tangent is what? Opposite over adjacent, so it would be negative 12 over 12, which is just negative 1. Okay, now let's talk the reciprocal functions. Okay, now when I do the reciprocal ones, y'all think about this. What's smarter? Would I take the reciprocal of this? Right, we would take the reciprocal of this one, wouldn't we? Because if I took the reciprocal of that one, I wouldn't have to rationalize. Okay, so the cosecant would be negative square root of 2. All right, and then the secant would be square root of 2. Okay, and then tangent, the reciprocal of negative 1 is just negative 1. Okay. All right. Can we skip this one? It's the same kind of problem. Only thing, this one would be in the third quadrant. Okay. Now, it says evaluate the trigonometric function using a quadrantal angle. Now, we're still finding ratios. So remember my saying, we're either going to draw a triangle or use the unit circle. Okay. In this case, 3 pi over 2, that's on my unit circle. Now, in this case, really, I don't think you would really have to look at the unit circle much because this one is quadrantal. Okay, so one thing about our 5-3, 5-4 quiz and our test 1 is we're going to need a unit circle. Okay, so be ready to draw that unit circle on our quiz Tuesday. Now, let's look at it and we'll review as we do it here. Where's 3 pi over 2 at? You probably don't know your unit circle quite as good yet.
Yeah, it's at 270.
Right, it's at 270. Okay, because what? This is pi, right? And then this is pi over 2. So this one would be 3 pi over 2. Okay, now, what's this ordered pair right there? Yeah, 0, negative 1. Okay, now let's review on the unit circle. What does the x-coordinate tell me? The cosine. All right, the y-coordinate is the sine. All right, a tangent is the sine over the cosine, which in that case it would be undefined. Okay, and then cotangent is cosine over sine. All right, now this one's asking for the sine. All right, so the sine there is just the y-coordinate, so it would be negative 1. Okay. You could actually put that in the calculator if you wanted to. I just thought of that. Now, what mode would my calculator have to be in? Radians, yeah. All right. I love these problems. These are fun. Okay. All right. So you have to satisfy which quadrant would satisfy that the sine is greater than 0 and then the secant is greater than 0. So what's a way we can say greater than 0 that's a little bit more easier to understand? What does greater than 0 mean? What kind of numbers? Positive. Okay? So you remember we have this. This tells us which ones are positive. What? All seniors take calculus. So all of them are positive in the first. Sine is positive in the second. Now if sine is positive, so is cosecant. Tangent is positive in the third. And if tangent is positive, so is cotangent. And then that's for cosine. So if cosine is positive in the fourth, so is secant. Okay? So watch how I just take it in parts. So where is the sine positive? first and second, because all of them are positive in the first. So that eliminates the third and the fourth. Okay, now look at the second one. Where is secant positive? Well, secant is positive wherever cosine is positive. So where would cosine be positive? In the two that are left, in the first quadrant. Okay. All right, I got several of these. These are kind of hard to catch on to at first, but they're really easy questions. And usually this is a quiz question. This one shows up on the quiz, or one like it. Okay. All right, let's try this one. Let y'all think about it while I draw it. All right. All seniors take calculus. Except for Bayless, you want to do doing wrong. So you want to do calculus. All right. Now, all right, sine is less than 0. So in this case, we're talking about, well, where is sine negative? Okay. So where would sine be possibly negative? Third or fourth. Okay. So it's positive there and positive there. All right. Now, where is secant positive? Secant is positive wherever cosine is positive. So where would secant be positive, in the third or the fourth? Fourth. Okay. All right. Now, this is the problem I was talking about with Christina. All right. This is the one where she got upset because she missed a sign. It's really easy to miss signs on these. Now, so when you look at it, I mean, it's kind of intimidating. You don't know where to start. It says find the exact value of each of the remaining trigonometric functions of theta. Okay. So again, when we're doing this, we're finding ratios. All right. When we find ratios, we're either doing the unit circle or we're drawing a triangle. So in this case, it's drawing a triangle. Okay. So, all right. Where should I draw my triangle? Quadrant 3. Pretty obvious there. Okay. I'm going to draw an angle in quadrant 3, form the right angle with the x-axis, and then theta at the origin. Okay. Now, this time, y'all see how it's kind of like the first question that we did? All right. Instead of an ordered pair, you have one of the ratios. So you use the ratio to fill in the sides. Okay. So you have cosine is negative 12 over 13. Now, cosine is adjacent over hypotenuse. So if we did adjacent over hypotenuse, okay, 12 over 13, now it was negative. Now that negative either has to go with the 12 or 13. It can't go with both. Now, what would logically make sense there?
13. Oh, wait.
Right? The 13 is the hypotenuse, right? And the hypotenuse is always positive. So it would go with the 12. Now, the other way that it makes sense is what the 12, it's going to the left, isn't it? Okay? Now, let's find our other leg, and then we can just name off the ratios. Okay? We name the ratios off the triangles instead of using formulas. Okay? They give you like formulas to use in the examples to find this. They actually give you the Pythagorean identity, like sine squared plus cosine squared equals 1. And you like plug that in and find the other one. And I don't like that. It's just so much easier to draw a triangle. Okay. Now, do y'all know that triple? 5. Okay. So 5. Sound good? For Christina. It's got to be negative. See how easy that's to miss? Okay. Because, hey, that's 5, 12, 13. That's my triple by the Pythagorean theorem. 5. But if it's going down, it needs to be negative. Okay. The way you guard against that mistake is if you make that mistake, you go back at the end and you say, well, all seniors take calculus, so my tangent and my cotangent ratio should be positive and the rest should be negative. Okay, and that wouldn't work out. So they've got the cosine, so you find the sine. Okay, what else is left? The tangent. Okay, all right. Can I skip over filling them in? You okay with that? Okay. So once you get the triangle drawn, all right, it's just old hat problems there. You're just filling in the ratios. Okay, now this one's in quadrant 2. This is the one that actually Christina missed. Okay, it was like this one. All right, so it went in quadrant 2 on the right angle. All right, now sine is what? Opposite over hypotenuse. So this would be 5. This would be 13. There's that triple again. 5, 12, 13. Okay, anybody want to say anything there? Negative 12. That's what she missed, is she missed that. Okay, I think that 5 and the 12 are actually swapped, but all right, that would be negative, and then you can name your ratios from that. Okay, now reference angles. This is the only time that we use reference angles in here, is just to answer a reference angle question. Okay, all right. We did these like a long time ago, like 3 weeks ago or something. All right, now remember the rules. All right, if it's in the, that's in the second, so you subtract it from 180. If it's in the third, you say the angle minus 180. If it's in the fourth, you say 360 minus the angle. And if it's in the first, it's the same. Okay. Now, if you don't remember the rules, draw a picture. Okay. So a reference angle, this is the angle, let me back up. It's the acute angle formed with the x-axis. Okay, so, all right, we know 176 should be in the second. That's not too accurate there. Should be closer to the x-axis. Now, the acute angle formed with the x-axis would be that angle, wouldn't it? Okay, so what would be incorrect about that one? Yeah, that's with the y-axis. Okay, all right, what would be wrong with drawing an angle? That would be an obtuse angle. Okay, so it's got to be the smaller angle. So that's 176, and we know that's 180, then that's got to be 4. Okay, so you can always just draw those out, figure them out. Those are really easy questions. Now, for radians, all right, there's some shortcuts with radians, but it only happens with when you have it over 3 or 4 or 6, which is most of the time what you have. All right, so if my angle is some version of pi over 6, okay, so I'm going to do this, some version of pi over 6, okay, or some version of pi over 3, okay, or some version of pi over 4. The reference angle is just going to be pi over 6, and the reference angle here is just pi over 3, okay, and the reference angle here is pi over 4. All right, it's just a shortcut. Now, that only works with 6, 3, and 4, which is nice because that's the ones that are actually on my unit circle. Okay? Now, so let's do one for the sake of actually doing it here that's not like over this. So in this case, what would the answer be on this question? Pi over 6, that's it. Okay? Now, let's pretend here, let me add another slide. All right, what if it was like over 5 instead? Okay, what if I had 7 pi over 5 and I had to find the reference angle? Okay, anytime like in this case, I always draw them. Okay, I don't really try to follow rules to get it quickly, you just draw it. And when you draw it, always start over here at pi to figure out where it's at. Okay, so what I'm going to do is I'm going to rename pi in terms of fifths. So how can I write pi in terms of fifths? What? 5 pi over 5. 5 pi over 5 would still be pi. Okay, so now halfway to 5 pi over 5 would be 2.5 pi over 5. So every 90 degrees is like 2.5. So this would be 7.5 pi over 5. And then this would be 10 pi over 5, which is 2 pi. So you take your quadrantals and you write them in terms of this denominator right there. Okay. Now, so now you can tell where's 7 pi over 5 at in the third. Okay, about right there. So that's 7 pi over 5. Now remember the reference angle is the acute angle formed with the x-axis, so that would be this angle. So if I went from what, 5 pi over 5 to 7 pi over 5, that would be how much? What's this angle? 2 pi over 5. Okay? So that'd be my reference angle. All right. But most of the time, I mean, you can use this shortcut. It's going to fall over 6 or 3 or 4. If that's the case, it's just pi over 6, pi over 3, pi over 4, whatever it's over. All right. Let's look at this one now. Now this one's negative. So we could add 360 and find the coterminal angle. Okay. So let me see. Negative 145 plus 360 is 215. Okay. Now, so would 215, would that be my reference angle? No, that is the coterminal angle. Okay. So 215 would be in the third. So you could say 215 minus 180. It's in degrees, I don't really have to draw it. Okay, so if you wanted to draw that, you could. It's a long lesson. All right, this one should be pretty easy. It's over 3. Pi over 3. Okay, that's it. All right, now, here's where we're going to get away from what it says. All right, now, again, we're finding a ratio, right? It says exact value, but what we're saying is this is equal to some ratio, something over something. And so it does. We can't. It says can't use a calculator to do it. Okay. So we're either going to do a triangle, or what was the other option? Unit circle. And so that's what we're going to do. We're not going to use a reference angle. Okay. Reference angles are for losers. All right. I use this, and I live and die by the unit circle. I tried reference angles one year. Total flop. Could not do it. Okay. All right. So you go to 240. Okay. Let me bring my unit circle in here. How convenient is that? All right. So I'm going to go to 240. Now, how do I find the cosine? The x-coordinate. So it's just negative 1/2. Okay? All right. That's opposed to using a reference angle. We're going to use the unit circle. Okay? So, again, that's the point where on this next quiz and next test, we need unit circle. Okay. Cosecant, hang on, let me get this copied. Okay. Copy. Paste. All right. So this one says cosecant of 11 pi over 6. All right. So we'll go to 11 pi over 6. All right. How do we get the cosecant of sine? Okay. And which one is sine? Y. So it wouldn't be negative 1/2, but it would be the reciprocal, which would be negative 2. Okay? Who on reference angle? Okay?
Brown.
No, I don't have brown. That would have been really good. Birthday's in February. Just throwing that out there. Wireless mic. That would be like the best birthday present ever. All right. Now, these are like really intimidating. Okay? Pay attention. And these are on quizzes. All right? So, and what's really intimidating is the math in them. Okay? The actual putting in the numbers is not too bad. So, if it says find this exact value and you can't use a calculator, what it is, the calculator is going to give you like a decimal, and they don't accept the decimal. All right, so what you really have to do is you just look at the unit circle and you fill in those values. Okay? But sometimes doing the math gets a lot of people in trouble right there. It's kind of difficult. Okay? So it says sine of 5 pi over 6. So that's 1/2. All right? All right. Now, what about the cosine of pi? Negative 1. All right. All right. Minus. All right. The cosine of 5 pi over 6 negative square root of 3 over 2 times the sine of pi over 2, which is 1. Okay, so now we would multiply before we would subtract, right? This is where people get in trouble, is doing this math. This one isn't too bad. Right, this would be negative 1/2, okay, minus, right, negative square root of 3 over 2 times 1 would be negative square root of 3 over 2. Now, yeah, is that okay so far? All right, now instead of minus and negative, we just say plus a positive. And now what they want you to do, I don't know if they'll actually take it like that or not. I would write it this way. I know it'll take it this way. You could, since you have both denominators are 2, you just write it as a common denominator. So negative 1 plus square root of 3 over 2. Okay, so let me do this, because where people get in trouble with these questions is the math with the radicals. Okay, the radicals like really stump people right here. So let me do like a little radical review. All right. So a lot of times what you get is usually like a square root of 2 times a square root of 3 type thing. All right. So can I say right there that's square root of 6? Yeah. Okay. Now, could I do like square root of 2 plus the square root of 3? Is that square root of 5? No. To combine radicals, the radicands have to be the same. All right, now it's helping, I think it was Cole with a problem last period, and he had something like this. He had negative square root of 2 minus square root of 2. Okay, what would that give you there? Yeah, negative 2 square root of 2. Did you follow, Bree, you follow that okay? Because it's like, what are you like really saying? Negative 1 minus 1. And so when you get to add and subtract, the radicands have to be the same, and it has to stay the same. Okay? That's where usually people get in trouble on these questions. All right, let's just try this one. Let me get my unit circle back up here. All right. Now, this says the sine of 21 pi over 4. Now, where's 21 pi over 4? Oh, no, it's not on there. So what do I need to do? It's too big, right? You subtract 2 pi. All right. So, all right, Bailey, do it for me real quick. Just take 21 over 4 on the calculator and subtract 2, and I think I have to do it twice, probably. All right. So, yeah, the coterminal angle is 5 pi over 4. So it would be the same thing here. All right, now we can find it. Okay, so sine of 5 pi over 4 would be negative square root of 2 over 2. All right, now the cosine of pi over 3 is 1/2. All right, so they're multiplying right here, okay? So they times 1/2, right, plus, now, cosine of 5 pi over 4 would be negative square root of 2 over 2 again, right, times the sine of pi over 3, which is square root of 3 over 2. Okay? Now, this is where people, everybody gets this part, but then they mess something up. Okay? I was helping, I was helping Callie with a question last period, and she did this. She did negative square root of 2 over 2 over 4. Because when I multiply, do I keep those the same? No, you multiply them. So it should be square root of 2 over 4. All right, now let's do plus. Okay, now, so what about negative square root of 2 times square root of 3? Can I say negative square root of 6? Yeah, we can multiply them, right? It'll be negative square root of 6. And what, not over 2, but over 4. All right, now I'm going to just put them all over 4 since I got a common denominator. All right, so it'll be negative square root of 2. And then plus a negative just means minus. And then square root of 6 all over 4. This comes from, that's a 15-degree angle. We're doing like summing differences. Summing differences of angles to get the 15 and the, I remember that. That doesn't look familiar? Okay. Yeah, I might not have done those. So that might not be a Saxon thing. Now, I got one more thing. I got to get it from the other. I forgot to put it in this year's file. Can you give me a second? Let me pause. Forever. All right, but this won't take long. Okay. These are what I call easy trig equations. Now we're going to get to a lesson later. I think it's like lesson 6.5. It is really difficult. Okay, it's the hard trig equation. Now these are the easy ones. Basically, they're like unit circle questions like we did earlier, but they're backwards. Okay, so instead of finding the ratio that goes right here, we're finding the angle instead. Okay, most of them, if it's not a quadrantal, most of them are going to have 2 solutions. Okay, so we're going to find out, well, where is the tangent? What angle would I take the tangent of to get -1? Okay, so let's look. All right, think about your tangents. It's what, the sine over the cosine, right? I mean, you could go all the way around with, so if I put this, oh, I did it backwards. If I put this over this, would I get -1? No. Okay, now if I put this over this, would I get negative? Now, that'd be close, wouldn't it? It would be 1, right? Because they're the same number. So all that needs to happen is just one of those needs to be negative, doesn't it? So how about right here? Yeah, that would be -1. Now, what's the angle right there? 3 pi over 4, 135. Now, which one do we put? All right, that's kind of a trick question right here. Watch. Look at the directions. The directions give it away. All right. So by that means you have to put it in radians. All right. So that would be 3 pi over 4. Okay. Now, a lot of times it's a couple of answers. All right. Y'all look. Where else would the tangent be -1? Would it 5 pi over 4, would it be -1 there? And that'd be +1. All right, so where else? Yes, 7 pi over 4 would give me a -1 too. Okay, so you have 2 answers, so you like separate it with a comma. Okay, so these are the easy ones, because all you're doing is you're just looking up where is this value on the unit circle and what angle is it. Okay, this one's actually easier. I probably should have started off with this one. Okay, so all right, where is the cosine 1/2? So I'm going to look. The cosine is the x-coordinate, so I'm going to find the angles where the cosine is 1/2. So that would be pi over 3, okay, and 5 pi over 3, right? These are really easy questions here if you know your unit circle. All right, so it's just another reinforcement there of why we need that unit circle on this next quiz, okay? Because there's a bunch of questions on it. All right, that's all of 5.3 with sound. No, I was messing with my microphone that day, and exactly. You know,